All right, welcome back to my channel. Coming at you with a sick video. I'm very sick, so you'll have to excuse the coughing and stuffy nose. I'm gonna read more in this book, and I'll see how I'm feeling. If I'm just too sick to continue, it might be a short one. But we're at structured outputs, so let's continue from there. Often in production, you need models to generate outputs following certain formats. Structured outputs are crucial for the following two scenarios. Number one, tasks requiring structured outputs. The most common category of tasks in the scenario is semantic parsing. Semantic parsing involves converting natural language into a structured, machine-readable format. Text to SQL is an example of semantic parsing where the outputs must be valid SQL queries. Semantic parsing allows uh, semantic parsing allow users to interact with APIs using a natural language, for example, English. So I don't know if that allow needs an S or not because I'm sure it's fine. For example, text to PostgreSQL allows users to query a Postgres database using English queries, such as what's the average monthly revenue over the last 6 months, instead of writing it in PostgreSQL. Yeah, so PostgreSQL queries, for anyone who doesn't know, uh, can be quite difficult, and it's very easy to make mistakes. So let's look at some examples of uh, post Greece uh, queries. So like here, yeah. So here's a good example of one. It's basically its own programming language. We can see select PID. What is that? As process ID. Oh, I guess it's a process ID with comma query. So now there's two of them for just one. As active query from PG stat activity where state equals active. So it's a programming language. It's another kind of programming language. So it's can be nice to use natural language to interact with the database rather than a domain specific programming language. This is an example of a prompt for GPT-4o to do text to regex. The outputs are actual outputs generated by GPT-4o. System prompt. Given an item, create a regex that represents all the ways the item can be written. Return only the regex. Uh, so here's an example. So we've got a U.S. phone number. Now you got to check these. I would not trust. I would not start. We'll see how long I can go. But I would not trust the AI to get that right. But luckily there are a lot of very easily uh, tools where you can check it. Um, so oh I wrote down SQL checker. I want to do regex checker. There we go. So regex 101 is a great site. So this should be matching. Oops. Uh, uh, there we go. Okay. So sorry about that. I should probably mute for that, but let's check some numbers. I'm not going to put real numbers in there, but let's see if all fives is a valid number or not. And there we go. We've got a match there. Let's see if 5-4 is a valid number. Now let's do a little bit of a stress test. Let's see if 0 5 5 is a valid number. So now we can see we did get a false positive match. 0 5 5 would not be a valid area code. In fact, um, there are many invalid area codes. The valid area codes only extend, only start, they extend through the range 200 through. So here we go. This is what we need to see. This is the NANP valid area code prefixes. So it extends through the range 200 through 999, less than 1,000. And then not all area codes are valid within that range. So it looks like 200 is some of them that don't have the links potentially are not valid, are just free area codes ready to be allocated to a new area if such need arises. Um, there's also area codes like area code 600, the numbers in the range area code 600. Um, for specialized telecommunication services. So, um, it's a simple example from the book, but it's a good example of how AI can fail because you're thinking like, given an item, create a regex that represents all the ways the item can be written. Return only the regex. U.S. phone number. Wrong. That's not all the ways that the item can be written. It can't be written with any digit for the area code. There's only these valid digits for the area code here in this table. So, blah, 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 it failed. It failed hard. So this is the world we might be entering, where people are doing this, and they look at how long it took me to look that up. It took me what 30 seconds, a minute to find this table on Wikipedia of all the valid NA and P prefixes. AI ain't gonna do that. So this is the world we're entering, where things just aren't thought through very well. For what took me a minute, would get me to a better regex than what the AI could do after hours of prompting, probably. Well, I don't know about that because you could give it more sophisticated prompts. You could feed it those, and but, you just have to work with it. This is a simple example. It's not really charitable to say that this proves a failing of AI, but it is, I think, fair to say that we might be entering this world where the abandonment of real experienced programmers leads to really disastrous results. All right, so the next example is a user prompt. So it'll give me, and let's do this. Let's follow along with this and just see, get curious about what I get. And I'm going to use the same model. They're using 4.0. Sorry about that. I know it's coughing is probably not fun to listen to. It's not fun to do either. And ChatGPT is down. It goes down every once in a while, so that's okay. Let's move on. So okay, so here's okay. So the next one is ChatGPT dash 4.0. So we've got a regex for that. I don't know. That's kind of an odd example. I don't really understand it very well. Why is it? Yeah, and I feel like U.S. phone number should be in bold. All right, but yeah, and then I feel like this is missing output here. This should have the regex that matches a email address, and then yeah. So I don't know if these are typos in the book or what the deal is here, but I'm quite confused by uh, this example of a prompt for. Oh, I get it now. So this is an example of a prompt for GPT-4o to do text to regex. The outputs are actual outputs. Okay, well, where's the outputs? The outputs, user prompt. Oh, I see now. Okay, I understand this example, and this is important to understand because this is prompting. These are examples of prompting. So what you would do is you would give it a like a system prompt. I don't know what that means. Um, but and then it says, uh, given an item, create a regex that represents all the ways the item can be written. Return only the regex. And then next we have a few shot example. If you give the prompt anywhere from 1 to 3 examples of the output that you want, then it can respond with much higher accuracy and usefulness than otherwise. All right. Oops. And I've got a annoying uh, device here that it keeps flashing at me. So I'll just close the lid on it. All right. So we've got a few shot example there. The U.S. phone number regex would look like that. So next we have the user prompt. So we're going to give it this first part of what we gave in the example. So we're going to have email address instead of US number and an arrow, and then it will fill in for an email. So we can see, um, here's the at symbol, here's the dot, and then, dot com, dot whatever. It has to have more than 2 letters at the end. So got that one right. Next one would be the dates. Um, okay, so there we go. Other categories of tasks in this scenario include classification, where the outputs have to be valid classes. Okay, and so that made more sense. This is just an example of prompting to do text to regex. So the most important thing of note, I would say, is that in this prompting example, there was an example, a high quality few shot example included. I would honestly still say this is a low quality example because, again, this is not the right regex for a US phone number. A US phone number, this regex appears to allow for any digit in the area code, and we can see the selection for area code digits is quite low. Um, all right. Okay. So moving on. Number 2, tasks whose outputs are used by downstream applications. In this scenario, the task itself doesn't need the outputs to be structured, and I'll do a sound check because my sound is terrible. In this scenario, the task itself doesn't need the outputs to be structured, but because the outputs are used by other applications, they need to be parsable by these applications. For example, if you use an AI model to write an email, the email itself doesn't have to be structured. However, a downstream application using this email might need it to be in a specific format. For example, a JSON document with specific keys, such as title, body, and body, title and body. This is especially important for agentic workflows where a model's outputs are often passed as inputs into tools that the model. Sorry. Oh, not fun, I know. Okay, this is especially important for agentic workflows. And let me check my audio again. Afraid I accidentally flipped my headphones off. Where a model's outputs are often passed as inputs into tools that the model can use, as discussed in Chapter 6. Frameworks that support structured outputs include Guidance, Outlines, Instructor, and Llama.cpp. Each model provider might also use their own techniques to improve their model's ability to generate structured outputs. OpenAI was the first model provider to introduce JSON mode in their text generation API. Note that an API's JSON mode typically guarantees only that the outputs are valid JSON, not the content of the JSON objects. The otherwise valid generated JSONs can also be truncated and thus not parsable if the generation stops too soon, such as when it reaches the maximum output token length. However, if the max token length is set too long, the model's responses become both too slow and expensive. Figure 2-20 shows two examples of using guidance to generate outputs constrained to a set of options and a regex. Alright, so generation constrained to a set of options. LM equals llama2 plus I like the color plus select red, green, and blue. Perfect. Yeah, so I like the color red, and there aren't any other options to choose from besides red, blue, and green. Okay, so the next one is generation constrained to regex. Um, LM equals llama2 plus question. Luke has 10 balls. He gives 3 to his brother. How many balls does he have left? And then the answer, you have to give a number. And the number can be, has to be a digit, but it can be any number of characters. Now, LLMs are non-deterministic, so I believe what that means is that the more, if you ask it this enough times, even though it is constrained, you might eventually get the wrong answer. But in this case, it does get the right answer. The answer is 7. So figure 2-20 using guidance to generate constrained outputs. You can guide a model to generate structured outputs at different layers of the AI stack: prompting, post-processing, test time compute, constrained sampling, and fine-tuning. Sorry, I'm checking my floor noise. Sometimes that is very high. The first 3 are more like bandages. They work best if the model is already pretty good at generating structured outputs and just needs a little nudge. For insensitive treatment, you need constrained sampling and fine-tuning. Test time compute has just been discussed in the previous section. keep on generating outputs until one fits the expected format. This section focuses on the other four approaches. Prompting. Prompting is the first line of action for structured outputs. You can instruct a model to generate outputs in any format. However, whether a model can follow this instruction depends on the model's instruction following capability, discussed in Chapter 4, and the clarity of the instruction, discussed in Chapter 5. While models are getting increasingly good at following instructions, there's no guarantee that they'll always follow your instructions. A few percentage points of invalid model outputs can still be unacceptable for too many applications. To increase the percentage of valid outputs, some people use AI to validate or correct the output of the original prompt. This is an example of the AI as a judge approach discussed in Chapter 3. This means that for each output there will be at least two model queries, one to generate the output and one to validate it. While the added validation layer can significantly improve the validity of the outputs, the extra cost and latency incurred by the extra validation queries can make this approach too expensive for some. Post-processing. Post-processing is simple and cheap and can work surprisingly well. During my time teaching, I noticed that students tended to make very similar mistakes. Interesting. When I started working with foundation models, I noticed the same thing. That's interesting. A model tends to repeat similar mistakes across queries. This means if you find the common mistakes a model makes, you can potentially write a script to correct them. For example, if the generated JSON object misses a closing bracket, manually add that bracket. LinkedIn's defensive YAML parser increased the percentage of correct YAML outputs from 90% to 99.99%. Wow, that's a good thing. Well, can I use the parser somehow? That would be nice. Uh, all right, well, this is the citation in the book, so this is probably a good one to go through, but I'm going to stick to the book. I am going to send this in my email, so I'll pause, send it in an email, and then be right back. All right, I'm back, so let's continue on here. Oops, and I opened VS Code. I did not mean to do that. Tip. JSON and YAML are common text formats. LinkedIn found that their underlying model, GPT-4, worked with both, but they chose YAML as their output format because it is less verbose, yeah, and it saves tokens, and hence requires fewer output tokens than JSON. So there you go. That makes a lot of sense. I thought there was another one. What was it called? Hamel? I thought there was, yeah, there's one that uses even fewer tokens than, oh no. This is for this is something else. But it's JSON versus YAML. Is it TOML? Is that what I'm thinking of? Yeah, this one uses even fewer tokens. Uh, I think it'd be great if we could ask the AI about it, but it appears to be down right now. All right, so moving on. Post-processing works only if the mistakes are easy to fix. This usually happens if a model's outputs are already mostly correctly formatted, with occasional small errors. Constrained sampling. Constraint sampling is a technique for guiding the generation of text toward certain constraints. It is typically followed by structured output tools. At a high level, to generate a token, the model samples among values that meet the constraints. Recall that to generate a token, your model first outputs a logit vector, each logit corresponding to one possible token. Constrained sampling filters this logit vector to keep only the tokens that meet the constraints. It then samples from these valid tokens. The process is shown in figure 2-21. So filter out logits that don't meet the constraints in order to sample only among valid outputs. So let's look at the. So here's the filter, and the constraints are output can only be red, green, and blue. So then that filter, so the input goes into the model, then it goes into the logits of entire VCAV. Remember what logits are. I don't, I don't though really remember what logits are. I wish I could get a refresher from ChatGPT, but I think it's down. Then it goes to the filter, then the logits of only the valid tokens go into the softmax, and then it gets the probabilities. In the example 2-21, the constraint is straightforward to filter for. However, most cases aren't that straightforward. You need to have a grammar that specifies what is and isn't allowed at each step. For example, JSON grammar dictates that after uh, comma, you can't have another unless it's part of a string, as in a key string, with all of the proper JSON syntax, the curly braces, and the quotes and all that. Building out the grammar and incorporating it into the sampling process is non-trivial because each output format, JSON, YAML, regex, CSV, comma separated values, and so on, needs its own grammar. Constraint sampling is less generalizable. Its use is limited to the formats whose grammars are supported by external tools or by your team. Grammar verification can also increase generation latency. Some are against the constrained sampling because they believe the resources needed for constrained sampling, interesting, are better invested in training models to become better at following instructions. Yeah, I agree with that. If your model's good enough, you shouldn't need to constrain it because yeah, and it shouldn't you shouldn't want to constrain it, right? It's like you want to be able to trust your model. All right, moving on. So fine tuning. Fine tuning a model on examples following your desirable format is the most effective and general approach to get models to generate outputs in this format. It can work with any expected format. While simple fine-tuning doesn't guarantee that the model will always output the expected format, it is much more reliable than prompting. For certain tasks, You can guarantee the output format by modifying the model's architecture before fine-tuning. For example, for example, for classification, you can append a classifier head to the foundation model's architecture to make sure that the model outputs only one of the pre-specified classes. The architecture looks like figure 2-22. The approach is called feature-based transfer and is discussed more with other transfer learning techniques in chapter 7. Alright, so this is figure 2-22, adding a classifier head to your base model to turn it into a classifier. In this example, the classifier works with three classes. So we got input going to the trained model, then to embedding, then the classifier layer, then we've got the logits, which go through softmax function and end up as probabilities. During fine-tuning, you can retrain the whole model end to end or part of the model, such as this classifier head. End-to-end training requires more resources, but promises better performance. We need techniques for structured outputs because of the assumption that the model by itself isn't capable of generating structured outputs. However, as models become more powerful, we can expect them to get better at following instructions. I suspect that in the future, it will be easier to get models to output exactly what we need with minimal prompting, and these techniques will become much less important. And not only that, I would even go further and say not only can we do it with minimal prompting, there's going to be a point where it can do it agentically. The minimal prompting is basically to have it perform autonomously as an agent, and it reaches out to you with the exact right output without a prompt or with a prompt so minimal that you set it up once and you get reoccurring output that requires no further prompting. I think that could come very soon. ChatGPT just released just released its tasks function, so we can see that that's where their minds are. The probabilistic nature of AI. The way, and that's what it said in Leopold Aschenbrenner's situational awareness as well, is the biggest buzzword you're going to hear from now to 2027. 2027, that'll be when we have a two order of magnitude increase in capability of ChatGPT 4. So it'll be the same kind of increase in capability as ChatGPT to ChatGPT 4. In 2027, that same sort of advancement will occur. So in ChatGPT 2, it could barely be coherent, and when it did create a coherent story or sentence, it was a groundbreaking research paper by one of the brightest AI researchers at the time. That moved on to a product for free called ChatGPT, and that was just a span of a few years, of 4 years. So this is what situational awareness says: is fast forward ahead to the next 4 years, it's inevitable that we'll have that same kind of growth based on the limitations and the trends so far. Now, there is a serious limitation, which is the data wall, but it's not so serious a limitation as to inhibit all of the other advancements. In fact, just having access to raw amounts of data is not even something that good for training an AI, because what you really need is high quality data. So it's not slowing down. Yeah, we can see it's. What does it feel like to stand here? So what it feels like is we get all these buzzwords just popping up everywhere that you've never heard of before, that but that people have talked about a lot. So I think one of them is agentic. Um, I forget where I heard this. Uh, yeah, so his big thing is it's gonna be like a drop-in remote worker replacements. So I don't know if I heard it here or if I heard it from Dwarkesh Patel's podcast. I watched the full 4 hours, but this is just. I would go even further to say that so the author suspects in the future it'll get easier to get models to output exactly what we want with minimal prompting, and these techniques will become less important. I'm a lot more, I think, bullish and optimistic. It sounds like the author is very measured and restrained in making this statement. I think this is obviously true as well. Like, yeah, the models are going to get way better. The probabilistic nature of AI. The way AI models sample their responses makes them probabilistic. We'll go over an example to see what being probabilistic means. Imagine that you want to know what's the best cuisine in the world. If you ask your friend this question twice, a minute apart, your friend's answers both sometimes should be the same. If you ask an AI model this same question twice, its answer can change. It's non-deterministic. If an AI model thinks that Vietnamese cuisine has a 70% chance of being the best cuisine in the world, and Italian cuisine has a 30% chance, it'll answer Vietnamese cuisine 70% of the time, and uh, Italian cuisine 30% of the time. So if you keep asking it again 100 times, 70, you'll get 70 answers of Italian and 30 answers of Vietnamese. The opposite of probabilistic is deterministic, when the outcome can be determined without any random variation. Yeah, so that would be great. That would be the next big advancement, is to get deterministic output where it can variably say the best cuisine in the world is one that meets this following criteria, and the only uh, cuisine that meets that criteria and can be defined as best is the cuisine produced by Michelin 4-star chefs, and this is the most common cuisine served by Michelin 4-star chefs. That's a much better answer than just randomly picking from a set of answers based on their probability, which is determined by the training. It's not even, yeah, I was tempted to say based on their probability that the answer is true, but that's not what it is at all. It's based on the probability that this would be the most commonly chosen answer based on the training of the model. So if the most common answer given is false or a joke or a meme, then it's going to choose that most of the time. This probabilistic nature can cause inconsistency and hallucinations. Inconsistency is when a model generates very different responses for the same or slightly different prompts. Hallucination is when a model gives a response that isn't grounded in facts. Imagine if someone on the internet wrote an essay about how all US presidents are aliens. This essay was included in the training data. The model will probabilistic, yeah, the model later will probabilistically output that the current US president is an alien. Yeah, so that's the thing too, is you can poison the data if you're not careful, and just add an option to that list of probabilities that can be chosen like 0.0. It's very unlikely, but the fact that it was included at all means that it's included in those probabilistic uh, choices. So it can that one time, that one jackpot, or royal flush, rare likely instance, it has the capability to really, really get things wrong. From the perspective of someone who doesn't believe that U.S. presidents are aliens, the model is making this up. Um, well, I mean, it's worse than that, right? It's like the model doesn't not only is it not deterministic and it's just pulling from a list of options. There's no guarantee that that list of options that it's pulling from probabilistically even contains the right answers at all. So it really depends on that training process and the quality of data for it to be even capable of giving correct answers. You just kind of have to trust that the people training it did it right, and there's kind of no way to verify that they did. And then not only that, there's a lot of really ambiguous moral quandaries where there really aren't any good answers. So like, where does its biases lie? Like what is it gonna tell you is right and wrong? And the answer is it will probabilistically determine that in a non-deterministic way based on its training, and it'll play strongly to its biases during training. Foundation models are usually trained using a large amount of data. They are aggregations of the opinions of the masses, containing within them, literally, a world of possibilities. Anything with a non-zero probability, no matter how far-fetched or wrong, can be generated by AI. This characteristic makes building AI applications both exciting and challenging. Many of the AI engineering efforts, as we'll see in this book, aim to harness and mitigate this probabilistic nature. This probabilistic nature makes AI great for creative tasks. What is creativity but the ability to explore beyond the common paths, to think outside the box? AI is a great sidekick for creative professionals. It can brainstorm limitless ideas and generate never before seen designs. Kind of. However, the same probabilistic nature can be a pain for everything else. I mean, AI is good for some things. I feel like what AI is really good for is reminding you of things you already like believe to be true. A great example is I bought kiwis at the grocery store, and they were like a rock. So like I thought they would get good overnight, so I just left them overnight, like on the counter or in my bag, and they weren't that great. So like I talked to the AI, I'm like, man, I got ripped off by these kiwis. They're not gonna ripen. And the AI is like, well, put it in a brown paper bag and leave it out on the counter because the brown paper bag will trap in gases that make the fruit ripen. Don't use a plastic bag because then um, the air has to mix in, like it has to be properly ventilated, and leave it on the counter. And like I did that in one of my, even though it didn't, I didn't wasn't able to leave it out on the counter as long as I would have liked because I was in a little bit of a chaotic environment. One of the kiwis turned out excellent. So yeah, it's definitely has its use cases. As far as like a creative professional or designer, I don't know. I feel like a lot of AI art is pretty bad, even today. Inconsistency. Model inconsistency manifests in two scenarios. Number one, input, different outputs. Giving the model the same output twice leads to very different, or the same prompt, rather. Giving the model the same prompt twice leads to very different responses. Slightly different input, drastically different outputs. Giving the model a slightly different prompt, such as accidentally capitalizing a letter, can lead to a very different output. Figure 2-23 shows an example of me trying to use ChatGPT to score essays. The same prompt gave me two different scores when I ran it twice. 3 out of 5, and 5 out of 5. Okay, so figure 2-23, the same input can produce uh, different outputs in the same model. And that's important because it's not actually grading the essay, right? It's just picking a probabilistic, it has no sense of what kind of essay would get a good score and what kind of essay would give a bad score, right? You have to give it few shot examples to even begin to have it make a accurate answer. Like it's just picking numbers not at random, but at the same time it kind of is. It's just rolling the dice, like it's playing D&D with you. Like that's not how papers are graded. Like it's not actually evaluating the criteria of the grade. So here's the example. User, you're a critical and unbiased writing professor. So, that'll help its probabilities. Give an essay, give it a score from 0 to 5. I put in the following format. Here's the essay. The morning sun casts long shadows across the brickyard as Lana makes her way to the first class, carefully dodging the bicycles of other students weaving in and out. So what is the essay score? The first response given was a 3, the second was a 5, and it's not scoring it. It's not actually doing what you ask. It's not giving it a score. It's pulling a random number based as if you were playing Dungeons and Dragons with it. It's rolling a dice, and based on the outcome of the dice, it's picking an answer. It's not actually evaluating the essay. Inconsistency can create a jarring user experience. In human to human communication, we expect a certain level of consistency. Imagine a person giving you a different name every time you see them. And it's worse than that because imagine someone calling you the right name, you know, every 7 times they say it, and then three for every 10 times they say it, they call you the wrong name. And that actually happens to me. I'm often called the wrong name. uh, but yeah, so AI is good, right? It's a lot of this is kind of a non-issue. Similarly, users expect a certain level of consistency when communicating with AI. For the same input, different outputs scenario, there are multiple approaches to mitigate inconsistency. You can cache the answer so that the next time the same question is asked, the same answer is returned. You can fix the model sampling variables, such as temperature, top P, and top K values, as discussed earlier. You can also fix the seed variable, which you can think of as the starting point for the random number generator used for sampling the next token. Even if you fix all these variables, however, there's no guarantee that your model will be consistent 100% of the time. The hardware the model runs the output generation on can also impact the output, as different machines have different ways of executing the same instruction and can handle different ranges of numbers. If you host your models, you have some control over the hardware you use. However, if you use a model API provider like OpenAI or Google, it's up to these providers to give you any control. Fixing the output generation settings is a good practice, but it doesn't inspire trust in the system. Imagine a teacher who gives you consistent scores only if that teacher sits in one particular room. Now that's interesting. If that teacher sits in a different room, the teacher's scores for you will be wild. The second scenario, slightly different input, drastically different outputs, is more challenging. Fixing the model's output generation variables is still a good practice, but it won't force the model to generate the same outputs for different inputs. It is, however, possible to get models to generate responses closer to what you want with carefully crafted prompts discussed in Chapter 5 and a memory system discussed in Chapter 6. Hallucination. Okay. Oh, you know what? Oh, shoot. I thought I was near a chapter and that would have been nice. Oh, I am. I am by quite a few pages though. So, let me check the hour mark because at the hour mark I'm usually kind of spent. So this is a pretty good. Let me at very least just move the bookmark forward and delete the old ones. Oh man, I'm only on page 181 of 900 pages nearly. All right, let's see where I'm at. If I'm at the hour mark, oh, I'm not quite at the hour mark. Uh, that's a tough call then. I don't know. Yeah, I think I'm gonna end it here. I just you know, I think that makes sense to end it here. So that's it for this video. Stay tuned for the next one where I go over the section on hallucination.